Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Yamaha CA-1010 natural sound stereo amplifier. So this is a special one. This was brought to me by a client. He wants full service. Apparently he was telling me he'd been looking for one of these for a long time. He had a nice one on his Ion in Eastern Canada, but the guy would not ship it, and I can understand why. These things are heavy, heavy, heavy. They are built with a lot of iron and aluminum inside because this is able to run in Class A mode. So we have a nice, very pristine. It looks very nice to me. I don't see any major flaws on it. There's a few tiny dings and the scratches on the face and the wood, but yeah, it's very nice condition. It's got a huge aluminum radiator on top. We all know why, because the center of this thing is going to be all heat sinking, and it's going to be an environment killer, that's for sure. But it's going to sound good. So you wanted a full service, which is going to be for me that replace all the caps. I don't know what's all involved with this thing, but we're going to get into it and we're going to find out if it has any issues. I think he wanted it full service because he just bought it and he was using it, and I think he's a little nervous not knowing its condition, if it's original unrestored or if somebody's been in here monkeying around before. Now I did have a look at the bottom panel, and some of the screws, you can tell somebody's been in there with a dull screwdriver and it's been in the bottom, so I don't know what to expect really. It's going to be fun. Been looking forward to this for a while. It's been sitting here for about a month waiting for the bench. Now it's on, so let's get to it. Let's have a look at the controls, the back panel, and then we'll have a look inside. Got a little incandescent light on it. Makes it look really yellow, but anyways. So we have a power switch, headphone jack, and our speaker selector. You have two sets of speakers you can choose from. Have power meters up top here. Peak meter, or these are actually power meters slash signal meters, because when the switch is out, it's reading in watts, and it goes from 0 to 200 watts on both the meters. And then when you press it in, it gives you an indication of your record out in millivolts, and there's a scale down the bottom from 3 to 1400 millivolts, and then it's measured in decibels as well. So either you can measure the output or you can measure your input signal, record out signal actually, which is line level. We have our normal Class A and Class AB switch. So when we flip this down, it sets up the amplifier Class A mode, and when we flip it up, it's normal AB mode for the amplifier. A 15 Hertz subsonic filter for phono enthusiasts, and we have a high cut filter of 10 kilohertz. In the center here we have a lot of controls. We have our mode switch: stereo reverse, normal, left plus right, mono left, so you can select your channels or reverse them. Have a phono selector here for phono 1. I think there is only one there. Yeah, there is only one phono here. This is for moving coil, 47K input impedance, 68K input impedance, 100K input impedance. Okay. Phono 2 is 47K input impedance. There is a Phono 2 on this. Maybe this is their selector. So you can select between Phono 1 of those 4 choices, or you get one choice on Phono 2. So that does have 2 phono inputs. Record out selector, so you can select your source that you want to record. Auxiliary tuner, record out off. I don't know why they would do that. Maybe to keep stray noise down inside. Phono, and then you can do your tape copy from tape 1 to tape 2. And we do have 2 tape loops. So we have auxiliary for input selector. We have auxiliary tuner, phono, tape 1, tape 2. And that's our inputs. Bass treble controls with a tone defeat switch when it's in the center, and when it's up high we have 500 Hertz roll off or 125 Hertz roll off. And then the same for the treble. We have a 2.5 kilohertz roll off or 8 kilohertz roll off, depending on how you like your tone controls to operate. And an audio muting here. So this is 0 mute, 0 dB mute, minus 20 dB mute. And then we can turn the preamp out off, which shuts off the audio to the main amplifier. And then volume balance control on the right. Very nicely laid out. And it's a typical Yamaha knobs, the rotary knobs, everything's brushed aluminum. So looks very nice. So in the back it's pretty sparse because they wanted a lot of real estate for this vent here. I'm going to let all this air in. There's quite a bit of ventilation on this thing because it's moving a lot of air and it's dissipating a lot of heat. So we got all our inputs taped 2 loops. We've got phono 1, which is blocked off right now, phono 2, tuner auxiliary, 2 tape loops, our turntable ground, preamp out from the preamplifier, main amplifier in with a switch to couple or decouple it. Okay, and then we have 2 sets of output for speakers, 4 courtesy outlets, 1 switched, 3 unswitched. Okay, I hope I have all this in frame. It's pretty big unit. It's to come off the top. So the top is real wood, and it has a nice screen to keep assorted things from falling into the amplifiers. It's got a nice, real veneer wood lid cover. So what do we got inside here? We have a massive, huge power transformer and a couple of 63 volt 18,000 microfarad caps, niche on Chemicon. Those are main filters. Power supply board down here is a relay. I don't know if that relay is a soft start or if that is a speaker relay. And this whole area in the center here is all power amplifier, mostly heatsink. 2 amplifier boards is wedged in the center. There's 4 devices per channel, so we're running tandem outputs. And then this is your inputs area here. We have phono probably under here, it's shielded, and we have the 3 shafts that transmit the rotary action to the switches that are back there. Now somebody's been in here because I can see somebody's already been writing on one of these boards. It's really dirty though. It hasn't been cleaned, or it looks like actually it's been partially cleaned. Alright, so here's a look at the input board, and this one has all the switching for the inputs, record out, stereo reverse, mono, and then there's I think 2 phono stages right here. This is our phono stage. It's got some tantalum caps around here, and it looks like it's original capacitors. It has a monster volume pot here. Look at the 6 gang volume pot. Try and replace that one, but looks like everything's intact. I'm seeing old capacitors, and then I'm also seeing new capacitors. Somebody who's been here and has done some work to some of these amplifier boards and replaced some of these caps. Because I see original ones, and then I look on the other one that it seems like they've been replaced. So somebody's been busy in here, and the screws are kind of mushed. Like it looks like somebody's had these out with a dull screwdriver. So these amplifiers have been out for sure. Seeing these boards here, this board here would be the tone amplifier, the tone controls, and what else has it got? Filtering, subsonic, and so on. This board's quite dirty. Looks like somebody cleaned this board but never cleaned this board, so it's quite dirty, and it's got like a layer of yuck on it. So we'll have to clean all that up. Alright, let's pull the bottom off. And the bottom is very clean. This is not normal for, it's very clean. So somebody's been in here cleaning, and look at this power board. So like some of these original caps, some of these have been replaced. You can see, I don't know why they pick and choose when they're going to do that. They should just do them all. Oh boy, same with Same with this. Got new caps on this board and original caps on this board. The tone board has all original caps. So I think what I'm going to do is I'm going to go through and I'm going to replace the caps that weren't changed. I don't think these blue ones here are new. I think they are originals. So we'll just give it a good service and check over everything. Looks like somebody's been servicing this already. Okay, this is starting to make sense here. So this Class AB switch here on the front is this, and it goes directly to this power board, which is mounted where that relay is mounted. So I think that relay is switching up for the amplifiers in Class A mode or Class AB. Alright, so I'll get started. Probably start first off with this power supply. I'll pull this power supply out and we'll see what's going on here. It looks like it'll just fold down. Look, that's loose. Heatsink is not, that screw's not even tight on that. Same with this one. That's no good. So we got to address stuff like this. This is a, voltage regulators. They got to have heatsink compound, and there's none, and the screw's loose, so those transistors are probably overstressed, and they're ready to pop. If they exceed their safe operating area, they will pop. So first thing I want to do is I want to take this, put it on the bench, we'll power it up and see how it operates, just to make sure it's all functioning well and there's no issues that I'm unaware of right now. Okay, so I got it wired in for a test tone and a pair of speakers. And let's just turn it on and try it out. You can see no lamps are on. Speaker protect relay kicked on. We're hitting 50 watts standby. I'm not getting anything here. What is wrong? I'm going to turn my output on. This is odd. Yeah. My goof up. I forgot the switch. I was playing with it earlier and I didn't turn it on. Okay. Let's go back to normal. We're on speaker system A. Okay, here we go. Both channels are quite scratchy. Pretty dirty switch. Muting switch, volume pot, balance pot. Just dirty switches and pots. Dirty switches and pots, lamps are out. I should ask the owner if he has any preference on a color, because if I do LED retrofit, I should ask the owner if he has any preference in color, because if I do an LED retrofit, you can pick any color you want, pretty much. And you can do that. It looks like the incandescents are both burnt out. 1, 2, I don't know how many incandescents they have here. 1, 2, 3, 4, 5, I believe. 5 of them, and they're all out. Okay. Let's Try this in Class A. And my one speaker's damaged and it sounds terrible. Actually, that speaker should be okay. We might have a distortion. Let's hook up a scope and see what it looks like on the scope. Alright, so we got it on 8 ohm load. Scope's hooked up. Let's turn this thing on. And we should have a signal. But we don't. Why don't we? Because I gotta turn this on. Okay, here we go. Pretty dirty. Dirty potentiometer. It's clipping. I did not. Let me change this. And go up to clipping. And go to channels. Everything looks good. Okay. Don't see any distortion. Let's try it on Class A. There's clipping in Class A. That's good. Okay, I don't see any problems other than controls, lamps, so let's go ahead and start on this. So whoever did replace some of these caps must have done them quite a while ago, because the bottom of the board looks all factory fresh, and it's got a coating of a film on it, like almost like smoke, unless somebody purposely did that. I don't think they would. But it looks like everything's, you know, it's got that smoky film on it. I don't see anything fresh here that's been resoldered recently. These nuts are loose. I can turn them by hand. These are the ones on the transistors. They're loose. Pull the relay out. I'll clean the contacts on that. And then we have probably some transistors that need to go here. These are the, let's see what, I can't read them. If I can read it. Two CA-1010s. And those are definitely on my naughty list. So those these 4 transistors will have to be replaced. And I'll look around and see if I can find any other ones. I don't know. The lighting here is terrible. To a CA-1918. Okay, yeah, and these need to be repaired. That's a joke. And then everything else needs cleaning. So the caps I'm pulling out, they're testing fine. They're actually testing high microfarads, which suggests that they're old and leaky. So they'll get replaced. I'm going to pull out a couple of the new ones that were put in and check them as well. If they're fine, they're going to go back in. I don't want to replace anything I don't need to. And then I don't see any cracked solders. Everything looks good that way. Oh, this here. I pulled this out. This is the preamp out, main amp in with the switch. This thing's been smashed, this connector, and somebody glued it all back together. The board, the foil trace is lifted. I'm going to have to secure that connection because that could break that foil. It's just hanging on by the foil trace. So I need to run a wire. I'll run a wire. This is a ground connection, so I'll have to run a wire for that. And the rest of it is, it was smashed, but it's all been glued, so it looks like it's intact. It's okay, I think. Alright, running into problems here already. Whoever replaced some of these caps in the past didn't put the right values in, or the voltages. For example, C403 C403 should be this one here on the board I just pulled out. And I pulled out a 22 at 63 volts. And this schematic says it should be a 10 at 25 volts. So did they just throw any old cap in they had it on hand and call it good? Or, you know, because this is in the protection circuit. And this is, I believe, this is the timing, for the timing of the turn-on sequence. So, do I put it back to 10? Do I leave it at 25? This is, you know, so I have to decipher this mess out. What else? There's other ones here too. Let's see here, 47 at 50, and they put in 47 at 63 volts. I guess, no, 100 volts. Yeah, 47 at 100 volts. I don't know why they did that. Plus 82. Oh, B2, B, okay. The highest voltage we have on this board is 64 volts. AB. 47 at 80. Maybe they put 100 instead. They didn't. You can't get an 80 volt, I don't think. So they probably put 100 instead. Okay, that makes sense. 100. Okay. So those I'll leave alone. But this one here has really got me baffled. This is a 22 at 63. I think I might just put in a, you know what? I'll just put it back in. It tests fine. These caps that were replaced have date codes on them, probably 1999, 1997. So they were replaced probably about 20 years ago. And it's seen a lot of use since then because, like I said, it's got that smoky film on it. So somebody's been using this amplifier regularly. Alright, so I pulled this relay. It's a double pull, double throw. It's got your common. Normally open, normally closed. Now, I'm looking at this. This one side looks great. It looks okay. The other side, not so much. Looks like somebody took some sandpaper to it. And there's a big gouge scrape in the middle of this one here. Looking at these contacts, looks like they've never been touched. So, whoever did a cleaning on this. So I'm just going to use the polish method. Get some polish on a cotton swab and polish it. And get these cleaned. I did measure contact resistance. Some of them are around 5 ohms. Some were good, around 72 milliohms. Some, I think one was 12 milliohms. And the other one, I can't remember. But there were some good ones, some bad contacts on here. So I'm going to clean them all. And we'll get this back in service. So this relay responded really well to cleaning. I got, here I'll show you this contact here. Close this relay. 6 milliohms. And the other channel. Here we go. 6 milliohms. And then the normally closed. We got 7 milliohms there. The other normally closed, 6 milliohms. So this one's ready to go back in service. Cleaned up really nice. Those contacts are silver buttons, so yeah, a little bit of polish, that's all you need. Alright, so I have the power supply board done. I gave it a clean with alcohol and removed all the flux. Now, I did replace 4 transistors on this board. There are two A844s and two 13 or two SC13s, 1213s. Sorry. It's a good thing I did too, because one of these two SC1213s has failed. It has low gain. It only has a gain of about 36 or so. The other one has about 150, what it should be. So for whatever reason, the gain's gone on the one transistor. But it's a good thing I caught it. Now it's been replaced, so this should be hopefully problem free. Relay's been cleaned, contacts are clean. Everything else, I left most of the capacitors alone because they are 105C capacitors and they're really fairly new, like within the last 20 years or so. And the other ones that weren't new got changed out. A couple film caps here where there used to be electrolytics. Won't be a problem ever again. Alright, now on to something else now. Here's a trap for new players. You pull the volume knob off. It's on a spline shaft and it just presses on, right? So you pull this knob off, and then you want to remove the balance pot, or the balance knob, and you start pulling on it, and it's not coming. So before you get your spoons out, look down inside here. There's a set screw from the side, and you can see it if you look from the side in. And yeah, it'll trip you up. Like, don't get carried away and start pulling on this, because you can actually rip this knob in half and damage the shaft on the pot. So all you do is position your pot so that the set screw is up or out, and just give it a few turns and it should back right off. Kind of awkward spot, but okay, so it should be loose. Well, maybe there's two. See, I got tricked again. Yes, there's two set screws. Don't let that fool you. There's another one. Now it's coming off. Two set screws. So I pull the front panel off and the meters come with, right? So there's your date code, 1977, 3rd month. And looks like these meters have cracks in them. You can see those cracks. It's just from the plastic aging. So eventually that's going to fall apart. Eventually it will fall apart with time, because this plastic is just deteriorating with age. So I'm just removing the power amps, and they're held in with these, I think these are M5 bolts. Now they're in very tight, and if you just try and get them out with a screwdriver, you're probably going to end up stripping the socket here. So what you do is, there's thread locker on the end. Just take a small butane torch and heat it up. Give it about 10 seconds on the butane torch. Make sure you move all the wires out of the way so nothing can get cooked. Heat it up really good, and it just comes right out like butter. So another tip for you. And then these power amplifiers are able to come out, and there they are. Oh gee, more loose heat sinking. Yeah, these caps will get all changed. Some of these have been changed already, like this one here. It's 1000 microfarad at 35 volts. Somebody put 1000 mic and 35 volts in there, so that's been changed. But the rest of them, they can go. And then there's also some transistors that will get looked at very carefully. You got some 2SC1213s again. You got one there, one here, one here. So we got a bunch of those transistors again. Here's another one, 1213, 2SA673. 2SA673 is not on my list, but it has that black leg disease. I'm going to take a good look at that one as well. I'll probably end up pulling all these transistors out and checking the beta on them, making sure that they're all good, and I'll replace the two SC-1213s with KSC-1845s, and then that'll be the end of it. Original silicon in here, and it looks like somebody has re-plastered the heatsink compound. They did a nice job of it too. Alright, I'm moving on to the phono stage, this board here. I'm going to remove this, and I'm going to remove this board as well, but I'm going to remove them as a unit. So what I'm going to do is I'm going to remove the volume pot with this board, just because of the number of connections that are shared between them. I'm not going to disconnect it. All I did was I disconnected 4 wires from the volume pot, and the rest of these are interboard connects, so they stay. I'll have to remove 5 from here, 6 maybe. I might do that. And then removed all the screws from the back panel. Okay. And then I split the chassis from the front, from the side here. You remove 2 screws, and then this allows you to spread it apart and disconnect the U-joints on the shafts. So that can come out. That's all disconnected. So all I have now is this nut. Let's do that right now. I'm going to take this volume pot out and service it because it was quite scratchy, and I'm going to remove it from the board and do a full clean on it. One of my viewers suggested using an ultrasonic cleaner for pots and switches, and I've seen it on the channel Mend It Mark. I'm sure some of you have seen his channel. He also does that. I'm just not sure about washing out lubricants. That's the thing, and then putting them back after when you're done. So I prefer disassembling switches. That way I know I can see the dirt's gone, or the corrosion, and this is how it comes apart. Now I got to release 6 connections here on this board, so I'll desolder these with solder wick, and that'll free the volume pot from the tone board. And then I can take these, how many screws I got here? 4 screws or 3? 2 screws here. And that should take this whole board out, minus these connections. So I'll get on that. So I got everything gutted from the receiver, or the amplifier. Got the tone board, and this is the meter board, a few other things going on. Volume pot, phono stage. So now I can focus on one piece at a time here, and I don't have to worry about wires breaking when I'm flexing boards. And this is a lot easier, and I can clean things better too. Look at this, I don't know if you can see this on camera, but it has some kind of gross film on it. And it looks like the dust from a couple decades, and then they just put alcohol on it and reflowed all the flux and embedded all that grody dust inside. Let me see here. Take a little bit of alcohol. Let's take a little bit of alcohol on a pad here and see how this looks if we clean it up. I like the bottom of my boards to sparkle. Look at that crap. It's all dirt, and I'll clean this up proper, but that's just an example of night and day difference. So yeah, we'll clean this all up, replace all the caps. I got a bunch of transistors here to replace as well. I can see them right now. I got these A673s. I'm going to check these. I'm going to pull them out and check them. If they're good, they're going to go back in. They're not on my list, but they do have the black legs, so it might cause problems. And then these pots and switches will all get serviced. My main thing is these switches here. These were causing a lot of problems, so these are going to be removed from the board, and then they're going to get cleaned independently, and then all these caps will be changed. Okay, everything's going in the ultrasonic cleaner, except I'm not doing these relays, probably because the relays have let's see here, this one here, I desoldered them all. This one comes apart, I think. The relay themselves is sealed. The reed relay is sealed, but the coil itself isn't. So I'm just going to take these off. I don't want water getting into them. I don't want water getting into the coils, that's why. Take those two relays out. I'm removing this pot assembly because I'm not going to chance damaging this pot in the ultrasonic. I'm not brave enough for that. Okay, removed the relay. This one's ready to go in. This one I desoldered 2 pots, so we can take this and remove these pots. Let's take this one out. There should be, oh, I missed one. Hang on. I don't know how I did that, but I did. Okay, this pot's coming out, and this pot's coming out. I think that should be good. There we go. Okay. So those 3 pots are removed. Everything else can go in. This can go in. So it's all going to go in the ultrasonic. Put that in now. Okay, let's have a look. Oh yeah, look at that. This is why I love my ultrasonic cleaner. So this was plain water, 20 minutes plain water. Took the boards out, scrubbed the back with alcohol for a few minutes, threw them back in, another 15 minutes. And you can see all the crud that come off these boards. So probably what I'm going to do is I'll drain this water out, put fresh water and run it one more time just to clean out any residues. The back is still filthy. I have to clean the back again with alcohol, because alcohol is the only thing that will touch rosin flux. But it's better than what it was. It's the tops look great. And then after this, after I do another 15 or so minutes with fresh water, I'll take them outside, blow out all the switches and components with compressed air, let them sit in the sun for the afternoon, and then I'll call it a day. Okay, here's the board out of the cleaner. It's next day. It's all dried. Now, look at the back. Okay, you're, oh, that's horrible. That's terrible. Not really. It's just rosin flux that got redistributed around and mixed in with the water, and this will clean right off. It'll look like brand new when I'm done. But I'm not going to clean it right now because I'm going to do soldering on it, and I'm going to get this all dirty again. So I'll clean it when I'm done. Let's change these caps. I got 4 caps here, 2 here, 2 here, 2 here. So 2, 4, 6, 8, 10. And I've selected new caps here. Got the relays. A lot of people talk about brands, different brands. This is an Ashy brand cap. I don't know if focus is working on this or not. This is an RF series cap. It's got high ripple current. It's a very good cap. It's got 3,000 to 6,000 hours rating at 105 degrees C. Another cap I'm using is from Wyman. Here's a brand name, Wyman. I don't know, zoom in on this if you can see this. Pretty tiny caps. Here's the brand logo. And this is also 105 rated cap. This is the LKM series caps. I buy these in bulk. And these are rated from 7 to 10,000 hours at 105 degrees Celsius. So very high rated cap. This will far outlive the rest of the equipment, and we should never have another problem with it again. So you can get good caps. They don't always have to be Nichicons or Rubicons or Elnas. There are other brands out there that put out really good capacitors. So let's put some of these in. These are these are 100 microfarad at 25 volts. Okay, let's pull these out. Got 4 of them here. Where is my... my stuff together here. Okay. Let's pull these 4 out. I've got a few comments in the past says, oh, you have all these different color caps on your board when you're finished. Why aren't you using one brand or stick to one brand? Well, I'm not brand loyal. I know Nichicon and Rubicon make good caps, but they're also very expensive. And I can get the same quality cap or even higher quality cap for a lot cheaper if I look in China. They do make good caps. They make garbage caps as well. You just need to know how to avoid the garbage ones and pick the good ones. And another thing is, I don't believe in replacing all the caps with audio grade because there's really no point. In power supply sections where they're just filtering power, you really don't need a audio grade cap for that. So these are 10,000. Let's just quickly check them and see. Do this off camera so I'll just read the results out. Set up for read ohms. I expect these caps are good, and this one comes back at 103 megafarad, 750 milliohms, ESR. That's good. It's a good cap. 101 and 632 milliohms, ESR. That's good. 113 microfarad, 785 milliohms. So that one's really starting to get out of tolerance. And this one's 97, so it's down a bit. 817 milliohms, that one's going out of tolerance too. So they're not all balanced equal anymore. This is what I'm replacing it with, from 100 microfarad at 25 volts to 220 microfarad at 25 volts. And we're going to just quickly check the new ones. And this one reads 208 and 293 milliohms, so these will be good. So let's put these in. Just going to quickly clean this off, and we'll I can find my solder braid, getting down to the end of that roll. Generally what I do is I'll do all the caps of the same value on a board at once. For example, I have 4 of these 100 microfarads. They're all coming out at the same time. They're all going to get replaced at the same time. That way I don't get confused as to value, voltage. They don't get them mixed up. So we have marked positive on the board. It's not really clear, but the long lead is always your positive on your cap. So put the positive at the positive. Where is, okay. You can see how much smaller these ones are. Even they're double the capacity. And these caps are in the power supply for this board. So it's just going to be extra filtering for the power supply. That's all that is. Probably didn't need it, but it can't hurt. Okay, them all tacked in place, make sure that they're straight. And push a couple of these down a little more so they're all the same height. Look a little more uniform. And we'll finish it off. Isn't the recapping exciting? It's kind of oddly satisfying when you get it done and you connect it all back up and everything works perfect. Okay. Let's go for these two big ones. You can open the holes with the solder sucker. I like using wick. I just bought a bunch of new wick and I got lots here, so I don't mind using it up. Solder sucker also works just to get the hole open up. Okay, so we got a little bit of scraping to do here. We got glue. Got so many holes, extra holes punched in these boards. I don't know what they're doing there with that. Okay. So our old caps, these are 1000 microfarad at 6.3 volts. Let's see what they say. This one's 830 microfarad, 316 milliohms, which is bad. And this one here is 789 microfarads, 340 milliohms. That's bad. So we're replacing bad caps with good ones. And these are same value, same voltage, and they'll measure a lot better. These are 991 and 95 milliohms. So huge difference. Okay, positive and positive. They're quite a bit smaller too, aren't they? Oh, did I miss that one? Okay. Now we got 4 more left. These two here are 10 microfarad 35s. These are more power supply filtering, and I think I'm just going to leave them at the same value. Okay. Alright, where was I? Just got interrupted. Now it's 24 hours later, next day. See, this is why it takes me so long to do a repair, because life interrupts the work on the bench. And we can't put life aside. So, where was I? I was testing some of these caps. Oh, these two. Yeah, these two. I wanted to show you guys these two on the screen. So, I brought the second camera in, and I just bought a new second camera. I'm going to try it out today and see how it looks for doing oscilloscope and second camera duty. So yeah, you can see this is 1000 microfarad, 6.3 volts, and it comes back at 778 microfarad. And if I hit the ESR thingy, 360 milliohms, which on 1000 it should be somewhere down under 120 milliohms, so it's about 3 times higher than what it should be. So that one's done. And then this one here, let's try this one. This one is a little bit better, not much. It's still around that 20% out range. What is that? That's 17% out, which in my books is failing, and still got 317 milliohms. A little better condition than the other one. And then these two 35s, these are power bypass as well. So they're 10 microfarad at 35s. Let's see what these come back as. 10.5, 13 ohms ESR, which is high, I believe. 35 volts, should be around 3 ohms or less. Let's see this one. And this one's 10.7 at 12 ohms. So yeah, both those are done. So we replace those with these LKM series Wyman capacitors. I was talking about these. My point I was trying to make is DigiKey sells, oh yeah, brand name caps, and they're all certified and good, but their prices are crazy. Like, I can get these caps, these Wyman caps, for, where'd the second one go? I lost it. Okay, let's solder this one up quick. So like I was saying, those Wyman caps I can get for probably 1/7 of the price that I would pay for, you know, a DigiKey sourced capacitor. For example, these 4 caps here, I've got probably, my cost is probably 10 to 12 cents a piece. And if I were to get the same spec capacitor, which means, you know, 105 degrees C, 7 to 10,000 hour life, you know, high quality cap, at DigiKey I'd be paying 80 cents each. So that would be like $3.20 versus less than 50 cents. So that's the huge savings I make for my my clients. And so don't get stuck on one brand. Now don't get me wrong, DigiKey's fantastic because I've had phenomenal service from them. I've had, they have their overnight international shipping, so I'm in Canada and I can order something and have it in my hands. And I think the record is I've had it in my hands in 19 hours. So that's incredible. I think 20 hours is the norm. 24 hours is standard for me. But phenomenal service from DigiKey. This one is 0.23. Okay. Yeah, no complaints about that part, but I just don't like the prices. Availability is always good. They always keep everything in stock. No problems there. So they're a great company to deal with logistically. Just you're going to pay the premium for their service. I can order caps from China for like 1/5 or 1/7 the price. I have to wait 3 weeks, 4 weeks, a month sometimes for it to get here. But when it gets here, it's a great bargain. All right, enough of that rambling. Let's get on to finishing this board. Now, these two are in the audio circuit, the audio path, so they are going to get audio grade. So let's check these ones. These are 3.3 at 50 volts. Let's see how they fare up. And this is 3.9, 52 ohms ESR. This one here is 3.7, 58. They're both pretty tired. Here's a brand new cap. Let's check it and compare. You can see the difference here, 3.4 ohms, 7 ohms. That's more like it. So those two caps were bad as well. Let's replace these ones. And yeah, these are Nichicons. Oh, that one's damaged. It's got a big dent in this side. Yeah, these are Nichicons, so no problem with these. Just want to test this one. Yeah, it's good. Positive to positive. Looks good. I'll leave it at that. Okay, now we're done with the electrolytics. Let's what I'm going to do is I'm going to remove these 3 switches, and I'll do that off camera because there's going to be a lot of desoldering. I'm going to have to lift this up. This will do that right now. Just lift that up for temporary, and then I'll have to desolder all this with my pump. New caps are in, old caps are gone. Oh, I want to check some of these transistors here. Let's see, we have 2 on this side and 2 on this side. These are A673s. I don't believe they cause a problem, but I want to yank them out and check their gain on them anyway, just to make sure that they're still good. And we need to solder our relay back in, so I can do that too. What is holding that? There we go. Okay. Let's pull out one of these first. Where is it? Yeah, they got the black legs all right. Okay. I don't know what gain range this thing's supposed to have, but we're going to see right now. And it's testing. It's got 132. Okay, so I'm going to pull the other three out and compare. If they're all equal, pretty much, I'm going to leave them alone. If there's a lot of variation between them all, I'm going to change all four of them. All right. All right, got these out. Let's have a look at them. Mainly curious on how the Ultrasonics cleaner clean these switches. We should mark this case. Actually, you know what? Lettering faces up, so we're good. Only goes on one way. Okay, here's the mechanism that controls. This controls the amount of rotation, and it has a detent for each stop on the switch. Look at this little plastic collar is cracked and broken. See, this is a problem with these old switches, is they're going to start falling apart eventually, and there's no finding parts for these. Something you might have to 3D print. But if that falls off, what that does is it just holds this aluminum rod and engages in there so it doesn't spin free. Okay, quite a bit of corrosion still on these contacts. You can see them. This side has nothing, and if you look in the back side, there's no contacts at all. So everything's up front here. So let's clean this. Get some cotton swabs. I'm going to use 401B, one of my favorites. I'm just going to get this a little bit wet, and we're just going to rub off all of this black corrosion that we can get, because the Ultrasonic really didn't touch it. Now when you take a switch, oh man, look at that. Take a switch apart like this, you have to remember its orientation, because it has to go back the same way. Otherwise your switch contacts won't line up and your circuits will act really weird and bizarre, and you'll be scratching your head why it doesn't work. So be careful around here too. These little fingers are very soft and they will bend easy. So I'm just going to clean this up the best we can. It took a lot of grime off. So what I'm going to do is I'm going to turn this about a quarter turn. Actually right here. And then I can get to the other areas I missed. Okay. Now, of course, I can't get the underside of those plates because they're, unless I disassemble the switch, I'm not going to do that. There's just too much risk of ruining everything just by taking things apart. Just going to leave that. We're going to just clean the top side of the switch. Then we'll give it a treatment of this stuff. Very small amount. I'll put those on the contacts. There we go. So I rotate this quarter turn very gently, put it back to the home position, and then we can reassemble this. Now this part here, it looks like we washed out all the lubrication on the, so let's let's deal with this. Let's take this apart, and we'll relube everything. Okay. Let's take out this E-clip, C-clip. Let's do this different. Yeah, it's going to be difficult. I'm going to get a screwdriver in here. Pry out this clip. There we go. There we go. And this comes apart. And clean and lube this. A lot of dirt. Okay, clean these off. Okay, let's clean this better. Okay, reassemble everything. Okay. Smooth. Perfect. Okay. Let me see. What's our rotation here? I'm going to put so from here to there, and then from here okay, should be all right. Really simple to do these switches. It's just a matter of putting them back together in the right order. Wow, even sounds better. Okay, let's do a little bit here. Okay. Now we have to assemble this. Goes like this. Goes like that. Good. Close this up. We're done. It gets soldered back in. I'll do the other two switches and then we'll put it all back together. Alright, everything's done with the switches. Cleaned, relubricated, treated, put back in, tightened down, and soldered back in. So everything's good. Switches are done. Caps are done. Everything else is done. Relays put back in. Check these 4 transistors. So now it's just clean up and get it ready for putting back into the chassis. So I'm going to do is these pads here. These are all ground pads. I'm just going to reflow these because they get oxidized. And get them freshened up. A little fresh solder on them. And get the oxides off. Don't want any thick layers though. Okay, good. Now we pull out our scrubby brush and we're going to dose this with alcohol. And we'll scrub this clean. Some of you guys mentioned you like watching me clean boards. I don't know, it could be more boring than cleaning a board. But it's kind of satisfying once you clean it and you look at it. It's spotless and it looks great. So let's get this. I usually do this a couple times because doing it once won't get all the rosin off. You do it a couple times just to absorb all the rosin flakes. Okay, that's looking pretty good. Let's do this side. You do it in sections because doing the whole thing at once is just too much sometimes. Just focus on one area. Looking better. See how that rosin just comes right off? This is still dirty here. Do this part more and do this down here. Once I got it clean, I'll give it a good visual. Make sure all the solder joints are 100%. I missed some solders. We solder those. There's two here that aren't soldered. fix those up right now. How did I miss those two? Okay. It's better. Let's clean this up some more. Sometimes it takes about 2 or 3 scrubs to get the board spotless. And you get really thick rosin flux, you just scrape it off first. It helps if you scrape it with a screwdriver or something first. I think we're just about there. I think we're here. This looks good, so we can lay this down. Lay this down, let's solder this. Okay. The only thing about this is you get a lot of lint from my paper towels. They get a lot of lint. Yeah. All right, looking good. I'll check this over with a magnifying lens and make sure there's no cracks and no bridges, and then we'll this is ready to go back in. So without putting this on the microscope, I'll doubt you'll ever see it, but this joint here is cracked right here. The pin from mechanical stress has separated from the solder around it. Well, if I'll zoom in a bit, maybe you can see. You probably can't because it's just, I didn't see it until I got a magnifying glass on it. But right here, right around the tip of that pin is you can see it's a big crack. And that's right on the phono stage, phono number 2 input. So if the person was using phono 2 all the time, maybe you had intermittent channel, that could be channel dropping in and out. That's why you got to really have a good close look at these. And it wouldn't be a bad idea just to resolder them regardless of how they look. Because these RCA plugs, they always get stress from you plugging in and unplugging. It creates a little bit of movement and that cracks right there on that pin. Alright, so everything's been disassembled, cleaned, recapped, treated. All these pots have been treated, switches. A little note on the ultrasonic cleaning of these switches. I think it was just a big waste of time. But of course I just used water. Now, my feeling is, I put the switches in, they came out. It made no difference, zero difference on the contact corrosion, the silver oxide. It was still there. I still had to clean it off manually by scrubbing it. But what it did do is it flushed out all the lubricants that were in the switches and pots. Well, I didn't put the pots in, that's right. It's flushed out the lubricant that was in the switches, so I had to end up relubricating all these switches. So I'm not really a big fan of ultrasonic for switches at this point. Maybe if I find a different solvent, but I don't think it'll attack the corrosion problem in the switches, the main problem anyway. So I think it's just a waste of time. But it does a nice job on the rest of it. Makes it all come out nice and clean. Everything's been nicely cleaned off. Backs are being soldered, put back together. These are ready to go back into the chassis. And now I'm going to focus my attention on the power amplifiers. Alrighty, so here we go. This is the first power module that I worked on. And what I did is I desoldered the transistor sockets from the board, so I was able to remove the board without disturbing the nice job that somebody did pasting these up. So I'm going to leave these alone. I torqued them down. They're all good. They were tight from the start, so I'll leave this alone. Put that aside. I'll show you what some of the changes I made here. Capacitors. Okay. The previous tech made a few mistakes, I think. One of them was they replaced, now this capacitor here, in the schematic it says it's 100 microfarad 10 volts, but somebody put in a 10 microfarad at 100 volts. Now this is an input coupling capacitor for the signal. It doesn't need to be 100 volts. A 10 volt cap will work just fine because there's no heavy DC on this. It's just a line level signal coming in. So no need for a 100 volt cap. It should have been 100 microfarads, not 10. So that's a mistake on their part, and they made the same mistake on this board. So replace it with a audio grade 100 microfarad at 16 volts. Now this cap here is also this was a previous tech put a 1000 microfarad at 35 volts, only because that's the only value they had, it seemed. So this is actually supposed to be 1000 microfarad at 6.3 volts, and it is it's in a circuit where it doesn't see any voltage. So putting a 35 volt cap in here where it's very low voltage is counterproductive to what the capacitor is supposed to do. Another change I made is the board had 4 1 microfarad 100 volt caps, or 80 volt caps, electrolytic, and I replaced all these for film. Reason being, these are on decoupling for power supplies, and my reasoning was, why have a capacitor in there that has like a 25 ohm ESR when I can replace it with a capacitor that has the same value and a 2 ohm ESR, and that will help with filtering, I think. Now, another thing that's gone is all these loose heat sinks. They were all torqued down, and I put lock nuts on them, so they're never going to come loose again. And they've all been pasted up properly. These ones here I haven't touched yet, and some of these are loose. And yeah, so that's going to get addressed as well. Another thing, I replaced a bunch of transistors. These are 2SC1213s, and there was 6 of them on this board. Now I pulled out all 6 and tested them. One of the 6 transistors has failed, and it had low gain. It had a gain around 40, beta of about 40. And the other ones typically had about 130 to 140 beta. So they were still holding out, but the one has failed. But just a matter of time before they all fail. So I replaced all 6 of those transistors, and then I replaced a complement to one of the transistors that I replaced, just to make sure that it's a complement there, because that's a gain stage. And then that's it, I think. Oh yeah, these two are thermally coupled together. That's the way they were, so I put it back. New transistors. I moved this diode to the back side because I was trying to open up real estate here for 2 new trim pots. But my trim pots are the wrong type. The board sits vertical like this, and I want to be able to adjust it from the top, so I can't. I'll try and mount it like that, but the wires aren't cooperating. I might have to mount them at an angle. That might work. The trim pots probably are fine. Maybe I could just test them and clean them and put them back, but I wanted to give them new trim pots while I was here. Problem is, like I said, they don't fit the board. They fit the board if I mount them sideways, but then I can't adjust them from the side. I have to adjust it from the top. So either I order some more trim pots, or put the old ones back in after cleaning and testing, or I try and modify these ones. So I haven't decided on that yet. And that's it for this. Everything else checks out. I like these film caps, they're kind of tall and thin, and they don't obstruct the airflow, because this board naturally sits up like this and airflow goes up, and these capacitors are not going to impede that. Plus with the smaller electrolytics, that's not blocking the airflow either, so that helps a lot too. And fixed up those heat sinks, so this should run a lot cooler now. Clean the backside. So until I decide what I'm doing with these trim pots, I'll put this aside and I'll start work on amplifier number 2. This one looks to be mostly the same, but see, these are the original caps here. 1 microfarad at 80 volts. Let me pull a couple of these out and we'll see how bad they are. Okay, let's pull one of these. Let's pull one of these out and see what it says. I have a feeling it's not going to be good. This is a 1 microfarad, 80 volts. And if I connect it up, we get 1.29 microfarad, which is 20%, more than 20% out of tolerance. 52 ohms ESR, which is not very good for a bypass capacitor. It's pretty poor actually. It really has little effect when you have a 50 ohm resistor in series with that cap. So we're going to replace those with film as well. Get the right values in here. Yeah, let's get started on this. Alright, so I got the second amplifier finished and it looks good. Now I did find 2 transistors bad on this board. They both had low gain, so that was a good catch, taking those out and checking them. These 4 transistors are heat sinked, and I got lock nuts on them just to make sure they don't go loose. You got to pay attention to this. The center conductor, this bolt is actually connected to the collector. 3 of these have a trace that backs it up. This one doesn't. This one, the trace is not connected. So I'm thinking of adding a bodge wire from the center pin all the way up down to here to make that connection, just in case this bolt or this screw and nut oxidizes or goes loose or whatever. It's not, they're very tight now, they're not going to go loose, but I think I might just add bodge wires on both boards, just because that collector would be isolated if this connection went weak. Another thing to mention about these Yamahas I kind of like quite a bit is they put these brass rivets on all these holes for here, for example, they put them on where the transistor sockets go, and they put them on here where the wire connectors go. Makes it a lot nicer and more robust. Now, soldering and desoldering on these boards, you'll probably end up lifting traces, but with these rivets, these eyelets, that won't happen, and that's a good thing. So Yamaha put a lot of thought into reliability of this thing, even though they didn't get it right all the time, but they did a good job on putting this together. So this one's done, except for the trim pots. Still haven't decided what I'm doing with those. Like I said, they're the correct value and everything, but they just don't fit the board because the adjustment screw would be facing sideways instead of up. So I think I might try and I don't know what I'm going to do about that yet. Think about that. So, found a bad transistor on this board, 2 bad transistors on this board, and got them fixed up. These are all been replaced, and ready to put it back together. This is the speaker output relay, and it had some pitting on the contacts, but what I did is I hit it with some 320 grit, 600 grit, and then finished it with 1000 grit, and I took out the majority of the pitting. These ones were not as bad, but these ones had a little bit more, so this is all ready to go. I did check contact resistance on this before I opened it, and it was actually pretty good. It was like 6 or 7 milliohms all the way around. So This is just preventative, and the pitting wasn't bad. It was totally serviceable. These silver button contacts, you can take off quite a bit of material before you run into trouble. But this one's good to go back in. So I'll solder that back in. Let's see here if I can figure out this way, I believe. Yep. Okay, another thing. We got some big ass caps here. 63 volts, 18,000 microfarad. They measure down around 10,000 microfarad, both of them. So I'm going to replace these. They're still good caps. Like, they got weight to them, and I didn't see any problems on the initial test. Like, you can tell a weak cap on a power test, but this didn't show up anything. So, but I'm going to replace them anyways. I got a good price on some 22,000 at 63 volts. They're a lot smaller, and they are going to work. So you have to, actually, all I need to do is drill. Let's see, get some light on this. I just need to drill a couple holes, and then we can mount the smaller caps on here. I'll need to figure out a method to hold them down, though. They need to be secured. They can't just be attached to the board and then left to flop in the wind, because you'll run into problems sooner or later. And this was the band clamp for the other two big ones, so that's going to be eliminated as well. I'll see if I can figure out something to secure the smaller ones down. Either use this and add some stuffing, or I don't know, I'll think of something here. But I'm definitely going to replace these. And it's a shame, because I think they still have life in them, but they don't measure what they should. Alright, so the new caps arrived. They actually were delayed by a day. And then I got busy with, we got a visitor over right now, so we're busy with that. So it's probably about a week later. But these are 22,000 microfarad, 63 volts. I got a good price on these. I think I paid around $8 a piece, which is pretty good for a cap that size. But they're quite a bit different in physical size, as you can see. So my solution, let me see if I can turn this around a bit. Got a problem here with my turntable. Okay, so what I've done is I marked out for drilling 4 holes. You can't really see. Let me get some more light here. Okay, you should see that now. So I drilled 4 holes, and these are 35 millimeter diameter. So I drilled the holes 36 millimeters apart. Okay, measured it out, drilled them 10 millimeters between holes. That's the spacing of the pins, and this should all just fit right in. Let's see here, negative that way. It fits right in there, and it's held in tight. So these are going to go in here. See if I can get this one landed. Just a little bit off on the hole, I think. Now, I've had them in here before, so they should fit. I can't do it without my eyes being there, so that's what it's going to look like. What I'm going to do is I'm going to secure it down to the board with some silicone adhesive around the base, and then I'm going to silicone the 2 capacitors together so that they bond together as a unit, and then that'll hold them together so that they're not going to be flopping in the wind like that. And then on the other side, where the holes came through, I just scraped back the solder mask, and we're going to create 4 new pads for these capacitors. And the old pads won't get used at all; they'll just be abandoned in place. All right, on to the relamping. The original 5 incandescent lamps were all burned out. Now these are kind of unique. Yamaha has a system where they have 2 pins. I removed the pins, but there's 2 pins on the printed circuit board, and then there's this rubber thing that connects it. So this is how it looks it would look on the inside. You have 2 pins sticking up in this rubber with a replaceable bulb. You could actually take this bulb out, these 2 wires, pull them out, and then you pull out your grain of wheat bulb. This is a 14 volt bulb, or it's supplied with 14 volts, 13 I think it says in the schematic, so a 12 volt bulb will work fine. And you can put your bulb in there, slide it in, take the 2 wires, fold them over, and then just slap it on the old pins here, and then you're done. You don't have to solder anything. It's pretty simple, pretty ingenious. But we're removing all this. We're not going to use that. I'm going to switch to warm white LEDs. You can see them in there. I'm going to solder them in. There's 5 of them. I'm going to solder them in underneath the color filter, like this. And then after this, we put the color filter in. Like, it's kind of a blue hue to it. And then there's the prism for facing our light pipe, let's say, for downward facing illumination. This goes above the meters, right? So it floods light down. The 5 LEDs are going to provide lots of light, more than ample. So what I'm planning on doing is feeding this from it's 14.2 volts AC, and that comes in on pin LA right here. It's an AC, so if I put a LED and dropping resistor, essentially what I'm doing is creating a light that only shines on half of the cycle. So you have your AC coming in, and then I put an LED. It's only going to light up, the LED is only going to light up on let's say the positive, and then it's going to be dark, and then it's going to light up, and then it's going to be dark. That's what happens if you put an LED on an AC with just a dropping resistor, because you're basically halfway rectifying. This isn't very good because you have a burst of light, then you have a period of darkness, and another burst of light, another period of darkness, and so on. What I'm going to do is I'm going to alternate these LEDs. I'm going to put one in positive this way, and then put one in positive this way, and positive this way. So they're going to alternate. They're going to be... So I'll have an LED that lights here, and then I'll have another LED that lights here, one here, and then another one that lights here, and then I'll have a more constant without the strobing effect. So that's my plan. So what I'll do is I'll put 5 LEDs in, and probably make cuts in the foil. I haven't decided where, but I'm going to make cuts in the foil, and then I'll just add a 2.7K chip resistor on the board here, and that'll be my dropping resistor for that LED. Each LED will have its own dropping resistor, and it'll be fed with AC, 14 volts, 14.2, and yeah, it should provide a nice, bright, warm white light. So here's the light bar, completely finished. You see I got 5 LEDs in there. I don't know if you can see that though, maybe it's not very good. There we go. And on the back side I got all my dropping resistors and all the modifications. Now just looking at this, you wouldn't think anything's been changed. It looks like it's all original, factory original, but if you look close enough, you can see where I put the dropping resistors. Cut a trace, put a dropping resistor. So that's my solution for this one. And it connects directly up to the 14 volts AC, and it provides a flood of light, and this will go back over the meters, and I think it'll work quite well. Anyways, we're down to the last bit here. Everything's put back and installed, except for we have not connected the power to the power amplifiers yet. We left this disconnected for a reason. We're going to do some testing on the power supply first, And let's see if we can get into this here. This part here, we should have produce a couple of voltages, a plus and minus 22 volts, a plus and minus 62 volts, and then see, this is kind of confusing here, because if I look at this, there's an A and a B. I don't know if you can see that, it's pretty tiny. An A and a B, and I don't know what they're referring to, different voltages for different modes. So I'm just going to go through and check some of these voltages on the output of this power supply and make sure everything's good. And then we'll move on to bringing the power amplifiers online and getting them set up. You do power up here. Let's turn it on. Like again, remember we have no power amplifiers connected, they're isolated. So let's turn this on. Stabilizes around 30 watts, 35 watts. Protect relay kicked in, 35 watts. Now it's dropping. 33, 34. Alright. So we have a number of voltages here. All these ones on here are AC inputs from the transformer, and all these down here are outputs. This is class A, class AB switching. So I got a ground, and then I got two AC lines, and then I have a B3 plus, and this should be 8 volts, and it's not, it's 12. This is supposed to be, where are we here? It's supposed to be 8.9 volts. Okay, we might have a problem there. And then we have a common pin. What's this? C. What is C? C might be the 0.4. Let's try this. C and B3 plus 8.5 volts. That might be correct. I don't know if C is a floating ground or if that is, let's see, I have to look at the schematic. It's supposed to have 8.9. But to chassis, it's not 8.9, it's 12. Can you see that? I hope you can. Okay. Let's continue on. B1 minus, right here. 67, B1 minus. It says it's supposed to be 30 volts. No, sorry, 62.7. Yeah, this is really hard to read here on this page. 62.7, so that one should be okay. That one's high. But also our line voltage is sitting at 124 volts, so we're going to get high results here. So it's C, B1, this is B2 minus, and this should be a 30 volt, 31, okay. And then there's a negative common, and B2 plus, there's our plus 31. B1 plus, and this should be a positive 67. Okay, everything's looking good. And then the rest of those are not voltages. Okay, very good. I think it's working fine. I'm still going to investigate that C. Where is... I want to investigate this here because I think this B3 plus should be 8.9, not 12. And that comes off this rectifier, goes through a couple transistors. There is, let's see here, maybe one of these transistors is kaput. 2SC1918 or 2SC789. I'll have a look at this closer. Alright, so what I did on this power supply is I pulled out both transistors and tested them out of circuit. They both tested fine. This 2SC-1918 had a gain of about 400, and just as an experiment I tried replacing with a 2SK-1845, and our voltage dropped a little bit. You see here it's now down to about 12.3. I think the problem is it's being fed with an overvoltage. Here on the schematic it says 13.7 going to the collector, and if I measure it's actually 16.4. So yeah, it's an overvoltage there, so it's an overvoltage on the way out too. And it's not really a regulating circuit, it doesn't seem to be. It doesn't do anything. It seems to be dependent on load too, because this actually, when I first turned it on, this was up around 14 volts, and then the relay clicked and it dropped. So I'm not sure if there's even a problem with this circuit. I think it's fine. I checked all the components, all the resistors are within tolerance, everything's good. But it's all this little circuit here, and nothing's bad. The main pass transistor tested with a gain about 100, and it's supposed to be over 50, and that's good. So I'm just going to leave it alone. I put a 2SK-1845 in there, and it seems no different. Slowly climbing up though. I don't know if it's a regulated supply. I don't think it is. Alright, I reconnected the power to this amplifier only. This one's still disconnected. So we're going to do power on and bias check, and check the voltage on the output. So this meter here is connected to the speaker output. This meter here is connected across the emitter resistor, and it's going to read the bias current. We have two adjustments, A and B. A is the adjustment for normal operation, which is AB operation, and then we adjust the other one for Class A operation. And then they tell us to start with the amplifier in normal, which is Class AB, and turn the coupler switch off to prevent any signal from getting in. I've done that. And we need an 8 ohm load on the output. So let me get that set up. So I think we're all ready to set to go. So here's the watt meter in the corner. We can see that. I'm going to be keeping an eye on this middle meter here, so that if voltage spikes, then we know we still have a problem. So here we go. Power switch. Okay, everything looks good. So we're down to 34 watts, 0 on the output, and we're down to 8 millivolts, which is low. So we need to adjust A. Let's see, A is for normal operation. Normal is VR301. Which one's VR301? I'll make sure I get the right one. Turn this up. 300 millivolts full scale. We've got probably 20 millivolts on the output. VR301 is B. So let's adjust B to bring this up to 25. I think that's the spec. I didn't mention that, did I? Yeah, the spec is for normal AB operation 25 millivolts VR301. A class operation 280 millivolts VR302. So VR301's first. Let's adjust this. Going down, let's go it the other way. Going up to 25. I'll leave it around 22 for now and let it warm up. Here's our consumption, 34.5. Okay, and we're still not bad. Alright, so we powered up the first amplifier in the one channel. Now we're going to go to the second one. This one's attached. They're both attached now. And let's turn it on. Swatch our consumption. Jumps up to 128. Clicks on. Drops back down to about 42. 41. And our DC offset is probably less than 10 millivolts. And this is our idling current here. So let's turn this one up to meet the rest, the specification. Alright, so we're there. Let's try it in A/B mode. Okay, there it goes. So now we're at 137 watts. And this is supposed to be at 280 millivolts, which is pretty much there. So let's adjust this one. Actually, I'm going to leave that one alone. Let's check the other one, the other channel. 222, that one's low. Let's turn it up a little. 280 is a spec. I'll leave it there for now. This has to warm up. So I'll be going back and forth between the two. It's already up at 280. So it's heating up pretty fast. So probably what I'll do is I'll let this idle in class B, A/B mode, and I'll let this warm up a bit. It's probably already warmed up enough from that little bit. And then I'll adjust this for 25. See, it's already 33 and dropping. So I'll give this about 10 minutes to stabilize, and then I'll adjust that for 25 on both channels, and then we'll call her done. I was pleased with the first little power up test we did. There's no smoke, no flames, no spark shooting out. So everything looks good, looks stable. We are able to adjust the bias, which is always a good sign. It tells you everything is working fine and healthy. So we got it wired in for a scope on both channels. I have my 8 ohm dummy load. We're going to go through and do a power test right now. So let's power this thing up. We're plugged in and we are going to get turned on. So here we go. Drops down to about 42, 41, 42, and stabilizes. It's good. Okay, we got 1000 hertz tone being fed in, so let's turn this up. And we actually have that's what I like to see. Okay, there's our clipping. Let me adjust this a little bit. Okay, let's see if we can get this. Okay, back it off a bit. Okay, so we are pushing out 28.78 volts RMS. And we're just going to let this cook for a while. Here's the timer. And we'll come back when something exciting happens. Or nothing at all. Here's what we're consuming. 368 total for the amplifier. My load's starting to get really hot. And looking good so far. So we're coming up to the 5-minute mark here. These heat sinks on this are pretty cool still. I don't even feel Oh, they're not even hot yet. But this thing, on the other hand, is radiating. I can feel the heat up here, and it is scorching. So a lot of heat going out the speaker terminals. But these are staying pretty cool. There's a lot of mass here, a lot of mass and sinking capability on these heat sinks. So I'm just gonna let it keep going for a while. Okay, so we're coming up to the 10-minute mark. This thing's full power for 10 minutes, and this heat sink is not even hot yet. That's amazing. I can put my hand on it. You can feel the heat, but it's not hot. It's just starting to get warm. This, on the other hand, I wouldn't dare touch because I'd burn myself. This feels like a hot soldering iron right now. So, yeah, we're over 10 minutes. This thing's proved its point. Let's turn this down and give it a chance to cool down. And we'll get rid of this. And let's do some other tests on this. Let's do some square waves. I'm interested to see how this is going to work. So give me a chance to set the controls up, and then we'll have a look at that. Alright, here we go. It's a 1000 hertz tone. That looks pretty good. Let's take it there to about there. Let's try that. There's bass cut. Oh, actually the tone controls are out right now. Let's turn the bass on. Bass cut. Bass boost. It's a different hinge on the filter. It looks like we might have a bit of a ringing on the top end there. Let's try treble. Treble cut. Treble boost. Things working good. This here is a mute. Mute switch works. This is a high cut filter, low cut filter, and then this is our Class A switch. Everything's working good. Balance, it's nice and clean. Pot's clean. No scratchiness. Okay, everything's checking out fine. Let's go up in frequency. Let's go to, see how high we can go with this and get a nice square wave. 6 kilohertz. 6 kilohertz, not bad. 7, 8, 9, 10. It's 20 kilohertz. It's pretty decent. And then if we go from there, it's going to turn into a sine wave. Probably around 42 kilohertz. Pretty good. Very good. I'm happy with this. So let's I'll finish the assembly, put it together. I got to clean knobs and face plate yet. Still haven't done that. Put everything back together, and then we'll do a final have a final look at it. Well, there it is. It's finished. Now here's a look of what the parts that went into it. A couple main filter caps, 4 trim pots, and the power amplifiers. 25 transistors I pulled out. 7 of these transistors have failed because they have low gain and they no longer meet spec, so they're garbage, but they were still in circuit and they were still working. So that's a good demonstration of you can have bum transistors in your equipment and it still sounds fine, still does everything like you expect it to. Just that when the gain deteriorates, then you start having problems. In this case, I don't think any problems showed up. Maybe there were problems if I listened to it, but definitely these transistors are a foobar. And then a small handful of caps. Most of them, some of them, about half of them failed. Some of these I replaced because they were the wrong value from the previous tech. Oops, they're going all over now. So pull those out, put the right value in, and but that's all sorted. And everything seems to be working good. So going to enjoy listening to this one for the next week or so before I give it back to the customer. And that's it for this one. So stay tuned if you want to watch more Yamaha action. I got another one coming up. It's a CA-1010, and that won't be for another few weeks anyways. I got a big project coming up. I got a Rotel monster receiver coming up, and I have a dual turntable. So those will be first. And thanks for tuning in, you guys, and thanks for watching, and hope to see you in the next one. Hope stay well.